Students, in this session, let us discuss about the performance of boilers. Generally, in the boiler performance is expressed in terms of efficiency of boiler. So before the efficiency of the boiler to be dealt, some of the terms to be known. Firstly, evaporative capacity of a boiler. The boiler's evaporative capacity is expressed in some of the ways, like what is the amount of steam generated per hour? That is kg of steam per hour. Second way is amount of steam generated per hour per 1 square meter of heating surface. Kg of steam per hour per meter square of heating surface. Third method is the amount of steam generated per kg of fuel fired. That is kg of steam per kg of steam per kg of fuel fired. So the evaporative capacity can be expressed in these three ways. Next is the factor of evaporation. Generally, it is defined as the heat received by 1 kg of water under working conditions to the heat received by 1 kg of water evaporated from and at 100 degrees Celsius. Here it is a ratio and expressed is a formula H minus HF1 divided by 2257, 2257. Next, the boiler efficiency. So generally the performance expressed in terms of boiler efficiency. If simply speaking, the boiler efficiency expresses how far or how well the boiler utilizes the fuel to convert into steam. So, the capacity of the boiler to generate steam for input of the fuel. Here, technically, it is defined as the ratio of heat actually utilized in generation of steam to the heat supplied by the fuel to the same period. So, it is a ratio of the heat actually utilized in steam generation to heat supplied by the fuel in the same period. Empirically, it is denoted by the formula MA into H minus HF1 divided by C. So here MA denotes the mass of water evaporated into steam per kg of fuel. C is the calorific value of the fuel. HF1 are the enthalpy values. Here, in a steam power plant, the boiler is used with heat acclimating devices like economisher, superheater. So these are considered as a single unit. Here, the boiler efficiency can be expressed as the overall efficiency of the boiler plant. So the units are added to the boiler. So it is as a single unit. Its efficiency is expressed as the overall efficiency. Now we'll look into the problem for understanding the boiler efficiency. So it is a sample problem. Steam used by turbine is 5.4 kg per kilowatt hour at a pressure of 50 bar and a temperature of 350 degrees Celsius. The efficiency of the boiler is 82% with feed water at 150 degrees Celsius. The question is, how many kg of 28,100 kilojoule coal are required per kilowatt hour? Second question is, if the cost of coal per ton is 500 rupees, what is the fuel cost per kilowatt hour? It is a problem. We are dealing with the boiler efficiency. Here in the steam condition is given the mass of the steam used, M is equal to, as per the question, 5.4 kg per kilowatt hour for 1 unit of power, 5.4 kg consumed. Then the steam pressure at the inlet to the turbine is 50 bar and temperature of the steam that is inlet to the turbine is 350 degrees Celsius. That is the superheated temperature. Efficiency is 82% and feed water temperature is 150 degrees Celsius. So in the question itself, it is given the calorific value of the coal 28,100 kilojoule. It is given, and for 1 ton, the cost of the coal is given as 500 rupees. So first we have to determine the coal consumption, and second is the fuel cost per kilowatt hour. First, the boiler efficiency. Here, the boiler efficiency is, as discussed above, is written, but in the formula is per 1 kg of fuel used. So it is denoted by MF. So MS into H minus HF1 divided by MF into C. Here MF denotes mass of the fuel used, kg per kilowatt hour. First, the steam condition, the superheated condition, pressure is 45 bar and 350 degrees Celsius. So from the steam table, from the superheated steam, we can have enthalpy of the steam is 3068.4 kilojoule per kg. So it is derived, taken from the steam table, from the superheated steam table. Next, the saturated in the same steam table, from the saturated water and steam condition, it's table. So the enthalpy at 150 degrees Celsius is taken HF1. It is 627 kilojoule per kg. Again, the efficiency of the boiler is given. So the only unknown is here MF, because the C, enthalpy, efficiency, all are known. So the only unknown parameter is MF, mass of the fuel per kilowatt hour. So from that, we can easily calculate the mass of the fuel per kilowatt hour. So it is 0.572 kg per kilowatt hour. So the first question is over. So per unit power generated, the fuel consumption is 0.572 kilogram of coal. The second question is we have to find the cost of the fuel. Second question is in the cost of the fuel per kilowatt hour. Okay. See, in the question itself is given for 1 ton, the coal cost is 500. That is for 1000 kg, the coal cost is 500. But we have to calculate the fuel cost per kilowatt hour. So we have to multiply 0.572. That is the mass of the fuel per kilowatt hour. So it is multiplied by 0.572. So for 1000 kg, the fuel cost is 500. For 572 kg per kilowatt hour, we can get the value of the fuel per kilowatt hour. We get the rupees. Again, we multiply by the 100. The mass of the fuel per kilowatt hour can be expressed in terms of pies. So 28.6 pies per kilowatt hour. So for 1 unit of power to be generated, the fuel costs 28.6 pies. So it is actually derived from the data given. That is for 1 ton, the fuel cost is 500. So only requirement is we go to again find the fuel cost per kilowatt hour power generated. This is about the problem using the boiler efficiency. Students, hope you have understood the terms and the problem very well. Thank you for your listening.